Okay, well, thank you very much, Q2B, and everybody who's attended today. It's wonderful to see so many friends in the audience, to give me the opportunity to introduce some of the work that our customers have been doing at AWS using Amazon Braket over the past 15 months or so since we launched Amazon Braket into general availability. It's been a really exciting time for us as we've learned with our customers about operating quantum computing in the cloud. And we've been able to work together to go to market, do joint customer calls together, learn how to operate these devices and integrate it into the holistic cloud environment. So my talk today is in two parts. The first part is kind of a more general overview of what we've been up to at AWS and quantum computing generally. I'll recap some of the announcements from last week that we made at the AWS reInvent conference. That's our big all of AWS customer conference in Las Vegas. We made a couple of announcements about quantum computing there, but it's a big conference, there's a lot of announcements. Some of it might have got drowned out in the overall noise, so we'll recap some of those announcements. And then in the second part of the presentation, I'll talk through a whole range of customers of AWS and what they've been up to on Braket and what we've learned from that experience over the past 15 months or so. So quantum computing at AWS, we've got a number of pillars of activity going on. First and foremost is Amazon Braket itself. So Braket is a fully managed compute service of AWS. It is just like any other form of compute for AWS. So we've got CPUs and GPUs and specialty processors in the cloud, and now quantum computers in the cloud. So Braket meets the same standards that any other form of compute does on AWS in terms of reliability and security and all of the integration that's needed into the cloud environment. The Quantum Solutions Lab is our professional services team. That's the group that works directly with customers on customer code. They do hands-on projects, write code together, develop intellectual property and so on with customers. The AWS Center for Quantum Computing is our fundamental research group. That's the deep R&D that's going on inside AWS into hardware, software, error corrections, and I'll talk some more about that team in a second. The AWS Partner Network is the group of value-added partners that we work with. So QC Ware, Zapata, 1Qubit, working with them to enable them to sell more to their customers and make use of the variety of AWS services, including Braket. And then we've got a worldwide specialist team, which is the group that helps our customers go to market, connects with the rest of the AWS field. We've got a worldwide sales force of some tens of thousands of people that are talking to customers on a daily basis. So how do we enable that field to have a good trust-earning conversation with all of the customers of AWS in a robust way? So that's the broad team. It's come a long way in the past couple of years as AWS has been building up its quantum computing capabilities generally, but these are the 5 pillars of activity that we embark on, and I'll touch a little more on each of these throughout the presentation. So the AWS Center for Quantum Computing on campus at Caltech. This is a AWS owned and operated facility on campus at Caltech. We're sharing some faculty and resources with the university, but for the most part, this is an AWS effort. So this is our own internal R&D program, collaborating with other partners in academia and across industry to execute on a long-term vision, a multi-decadal effort to address some of the fundamental challenges in bringing quantum computing to market. So looking at hardware, software, error correction, whole of cloud integration. About a year ago, the team at the Center for Quantum Computing published this paper on an architecture for a fault-tolerant quantum computer design. So more fault-tolerant, certainly not error-corrected yet, but a superconducting-based approach using a hybrid electroacoustic qubit, concatenated cat qubit design, which, if implemented, could lead to much better performance across those metrics there. So that paper's been out for a year now. And what the team's been up to is then implementing the designs in that paper. And so we announced just a couple of weeks ago some of the first results from that work in implementing that pathway to a fault-tolerant quantum computer. And these are some of the first photographs that we've seen of an AWS-produced quantum computing design. Now, I stress this is Still very much fundamental research. We're very much in the research phase. We're learning a lot. We've got a long, long way to go before a computer like this is available on Braket. But it's an indication of where we're headed as a company to produce our own hardware, to work with other hardware partners as well and create an environment where there are multiple devices of availability. There's a lot of choice for customers at AWS. That's true on classical compute as well. So in the classical compute side of AWS, there's Intel, AMD, NVIDIA, and also AWS's own chips for different purposes. And there's trade-offs to all of those. So it's about giving customers choice in what they're looking for, and that applies to the quantum computing world as well. If you're interested in more detail about the implementation of this work, we gave a presentation last week. It was last Friday at the reInvent conference in Vegas. Fernando Brandao, head of algorithms from the Center for Quantum Computing, and Nadia Carlson gave a great talk on the results from some of the work here. That video will be up on YouTube for everyone to see within a couple of weeks. So we'll post that out, look for some marketing from us on that, and you can start to see some of the results from the hardware side. So a little bit more about the Quantum Solutions Lab. Helmut Katzgrab is here this week. He's the leader of the Quantum Solutions Lab. This is our own team within AWS of specialists in quantum computing that work directly with customers on engagements. So typically working under a statement of work, multi-month engagement, looking at problem identification, algorithm formulation, testing on Braket, testing on classical implementation, so classical high-performance compute and classical machine learning, benchmarking that work, and then working with our customers to understand the pathway to implementation there. A lot of the work, and you'll see some of this later in the slides, has been around intellectual property development as well, so working with customers to create algorithms and applications that will work for them in their particular use case. So now to Braket itself. So Braket, fully managed compute service in the cloud to make it easy to explore quantum computing. And exploration really is the operative word here. It's an environment to build up the skills of quantum computing, help us all learn together what it takes to integrate quantum computing into a cloud workflow. So there's an environment to design quantum computing applications and workloads within Jupyter Notebooks, a software development kit, test those workloads on managed simulators within AWS's classical infrastructure in the cloud, and then run those workloads on multiple quantum computing hardware devices. So if we take a quick look at the high-level architecture diagram of Braket here, there's a couple of things to note. One is that Braket's part of the cloud. It's a fully fledged service of AWS, which means it connects into all of the other services of AWS. So security, identity management, storage, machine learning. If you want to do voice recognition with Alexa and combine that into Braket, you can do it because it all connects into the various services of AWS. The managed simulators sit within Braket itself, so you can enable and scale up very large simulators for quantum testing within the Braket environment, connect in through managed notebooks, software development kit, graphical user interface, and then of course connect to the hardware. So we've got 3 simulators available now. We've launched 2 this year. So we launched Braket into general availability last year with the state vector simulator. That's a 34-qubit CPU-based simulator running in the cloud that can scale out to many, many instances. So you can run multiple instances of this in parallel. The same is true for our tensor network simulator. It's based on GPUs, can run up to about 50 qubits. And we launched about halfway through this year a noise model simulator that better emulates the noise models of the NISQ era devices that we've got available today, and we can do up to about 17 qubits on those. So that's the simulators. On the hardware side, we launched with 3 different hardware platforms representing 3 different modalities of quantum compute. So quantum annealing with D-Wave, ion traps with IonQ, and superconducting with Rigetti. And it's been incredibly popular for our customers to work with multiple devices. So like we originally thought that people would come with a favorite device or a target device that they would want to use as a customer. But what we're seeing from our customers is there's a lot of testing and playing and trying out different things across the different modalities. Even customers that use annealing and then gate model and will try different approaches to solve the same problem at the high level but take different approaches to trying that out, test it out on simulators, test it out on different modalities. So the value of choice is really starting to come through with the user data that we're seeing. Now, one of the announcements from reInvent last week was to pre-announce the availability of 2 new hardware platforms that will be added to Braket in the near future. So another superconducting qubit architecture from Oxford Quantum Circuits. We'll have an 8-qubit machine available soon from the team at Oxford Quantum Circuits. That will be based in the UK. And then the Ware device. We've been hearing a lot about this morning. I saw that Alexander gave a great presentation over lunch on the properties of the Ware device. We're really excited about this because it adds another modality of compute to Braket. So it'll be the first Rydberg atom-based computer that's available anywhere, and provides an opportunity for customers to start to explore a completely different form of quantum compute. So analog Hamiltonian simulation, and taking on some of the new science that's possible with that device becoming available too. So look out for those devices becoming available on Braket soon. One of the other areas that we've been putting a lot of work into over the past year has been the hybrid quantum classical algorithm component. So for algorithms like VQE, QAOA, where there's a lot of interaction between the classical and the quantum compute aspects, so updating parameters, putting that to a quantum circuit, sending that back, managing that interaction in a cloud environment where the classical compute could be anywhere, compared to where the quantum compute is, that's a challenging process. And so our customers that have been working on these hybrid algorithms over the past year have had to self-manage that interaction between the classical part of AWS and the quantum part of AWS. So we announced last Monday the availability of Amazon Braket hybrid jobs. So this is a new feature of Braket. It's live now, it's in general availability. And so you can now containerize your quantum computing algorithm, the application that you would like to run, deploy that container, and AWS will handle for you the quantum and the classical elements of the compute. So within that one environment, we can help you set up, manage, parameterize, and optimize all of the compute that's needed to solve that one algorithm. So handling both the classical and the quantum piece all within the one environment. That includes the simulators, the quantum processors that we have to use. You can store your container in the Amazon Elastic Container Registry. So we've got a service for that. You can share those containers around, bring your own container, use some of our pre-built containers to do that kind of work there. I skipped over one of the key benefits. One of the key benefits of this approach is that every time you loop through the quantum classical loop, using the containerized service with hybrid jobs, we give you priority access back to the front of the queue of the quantum hardware. So you don't go back to the back of the line anymore. You come to the front of the line, and we can optimize the execution of that overall application, both the quantum and the classical side. And so the hierarchy now of compute on AWS with quantum looks like this. We've got, so building up, shots at the most basic level, then tasks, and now hybrid jobs. So shots being the single execution of a single circuit within the circuit model. Tasks are the repeated execution of that same circuit. So send it across once, execute many, many times, return the result. And now hybrid jobs, which manages holistically that quantum classical hybrid operation. You can do as much classical compute as you need to do, you can do as much quantum compute as you need to do, but it's all within that one environment. And so what we're seeing from our customers now is an ability to explore at each of these levels. So if you just want to send one shot across, see that a quantum algorithm works, and debug that, you can do it. If you want to repeat many, many times, say do a bell pair inequality, you can run that, and then once you're ready to do large-scale hybrid jobs using the classical infrastructure of AWS, that's available as well. So that's our activities at AWS and quantum computing in a nutshell. Let's take a look at how people are using it. So over the past year or so, we've seen Our users essentially fall into 4 different categories. So it's the research users of Braket, the independent software vendors that are building on top of Braket and on top of AWS and making solutions available, our partners who help other people make use of AWS, and then the enterprises that are doing work as well. And the way that we think about this is that our quantum hardware partners, Braket, IonQ, D-Wave, Ware, Oxford Quantum Circuits, they're providing the base level infrastructure there. Braket and all of the tools around that are providing security, the operational consistency, the integration into the rest of the cloud, a simple and on-demand pricing platform and a developer environment. And then our customers are building on top of that. So the value add to our customers is to build on Braket and enable research on Braket and be able to teach on Braket as well. So we'll step through a couple of examples of the customers doing this kind of work. So let's take a look at research first. So on the research side, here's a collection of headlines from across the year. We've been establishing research partnerships with groups around the world. And what we are doing here is enabling regionally focused research groups to get access to quantum compute and the classical compute on AWS to do that work. So we're partnering with regions in India, for example, the MITI group, which is the Ministry of Industry Technology in India, to seed ideas for quantum computing research, enable that research on Braket, and to assist with the publication and promotion of that work afterwards. We've been doing the same in Italy, in Israel, in Japan, and starting to build out that overall group on the regional research groups there. We've also been partnering with our quantum hardware partners and our quantum software partners to enable their researchers and their networks to get access to Braket as well. So partnering with the IonQ Research Credits Program, that's been a great initiative to enable more research to happen on the IonQ platform. And a couple of weeks ago, Strangeworks announced the availability of their Backstage Pass program, which will include a research component supported by AWS so that researchers can work through the Strangeworks platform if they wish to get access to various devices. And the mechanism that we use to do this is the AWS Cloud Credit for Research program. Now this is an AWS-wide initiative that we in the quantum computing team are working very closely with, and it provides funded credits to get access to AWS. So whether you're doing machine learning or some voice recognition stuff with Alexa or building robots or whatever you're into, the ability to access the cloud environment to do good research is what this is all about. But given quantum computing is at the stage that it is, this is an extremely popular mechanism for us to be able to allocate credits to researchers all over the world so that they can do this work. So if you're interested in this, if you're a researcher, you know a researcher, and you would like to get access to any of the machines that I talked about, drop me a note. We can get you through this program and get you access to those systems. So a quick couple of examples of work that's happened under this program, and we've seen published results come out already this year. This is some work out of QSoft in Cambridge and Caltech, a cross-platform benchmark analysis that used Braket to access the IonQ and Rigetti machines and do an advanced benchmarking framework through 6 structured tests for this work. So we're really pleased to see this work making use of the multiple computers that are available through AWS to do this benchmarking work. Another example, an optimization approach. So this is a mobile robot tracking and picking optimization problem to minimize the distance traveled in warehouses. And this was using the D-Wave Advantage accessed via Braket. This is one of my favorites. This is a tomography problem, so development of a classical shadows algorithm for quantum process tomography. The reason it's my favorite is that it came out of the Xanadu QHack program. So AWS sponsored the QHack event run by the Xanadu team back in February. A team that participated in QHack was doing so well, and it was so relevant to their master's level research that they continued to follow up with us. We gave them additional credits to do this work, and they recently published this paper looking at the tomography approach based on IonQ via Braket as well. And so we're really excited to see this kind of work starting to come out through Braket. It's not only using the multiple computers available, it's using the classical infrastructure as well, and allows us to connect into some of the other tools around AWS. We can help promote this work. We've got our own blog, so we can talk about things like low overhead quantum computing using fancy qubits. We've also got access to the whole of AWS science communication approach. At the reInvent conference last week, we had 8 sessions where we were talking about the science that occurred on Braket. So we're talking to the 50,000 or so participants that came to the AWS reInvent conference to update them on the science that was coming out of Braket's use. And of course, we're, just a plug for next year, in March, the 25th annual QUIP conference will be hosted at Caltech, and AWS is the diamond sponsor of that, and so we're looking forward to seeing a lot of work coming through that channel as well. So let's move on to some of the independent solution vendors that are developing on Braket. So this is our Build on Braket program, where we're seeing startups, established companies, larger companies building solutions on top of AWS and using Braket. So one example is Q&Co. They developed an application called QBEC, which is a platform for doing chemistry and material science simulations. I've included the link there to the blog post describing the detail here. But there's something that I want you to take away from on this slide, and that is that the Braket logo, which is the one with the little ion going around it, that's just one of the logos in use on the AWS architecture there. So the customer is not just using quantum compute, they're using the classical compute components of AWS as well, connecting into Braket, using storage, using databases, using the other facilities there to create a holistic solution and build on top of AWS. So Braket's just one piece. Similar for Ware. So Ware also building on Braket. They've built their Forge platform on top of Braket. You'll see in the screenshot there that within the Forge environment offered by Ware, you can access the multiple devices that are available through Braket, including IonQ, Rigetti, the simulators, and D-Wave. But it's not just the quantum computing side. The Forge classical implementation of their CPU and GPU algorithms is also running on AWS. It's not running on our simulators, it's running on the AWS classical infrastructure that we offer as well, creating that holistic solution. If we look at the enterprise space now, so one of our customers is JP Morgan. So Marco Pistoia and his team at the JP Morgan Flare team, they were one of our early users of the hybrid jobs feature that I mentioned before that we launched last week. And they ran through a portfolio optimization test using QAOA using hybrid jobs. Now, I'm not going to steal Marco's thunder because he does a much better job than I do explaining this, but that too was recorded last week at the reInvent conference. And so Marco's presentation will be available in a couple of weeks on YouTube. He talks through exactly what JP Morgan are doing to implement this technology on the hybrid jobs architecture. So it's a great opportunity to follow up and see how that process unfolds. One of the points he makes through it, though, is that it was the integration into some of the telemetry tools of AWS that helped them do this work. So the Amazon CloudWatch environment for notifications, and also our cost management tools to optimize some work there. BMW, over the past 6 months, we've been running the BMW Quantum Challenge with our partners at BMW. This is an open innovation challenge to explore multiple use cases in quantum computing. We worked with BMW to define and then seed ideas for 4 challenges in machine learning and sensor placement and some optimization problems. And this has been a really neat program to not only get a lot of activity happening in quantum computing on some well-defined challenges, but to see that work come through on Braket and some other platforms as well. I'll talk a little bit more about that in a second. But that blog post link there, that talks to you about how we identified the process that we went through to identify the 4 use case challenges that we launched as part of this. And the winners of that program will be announced here at Q2B on Wednesday. So Helmut Katzgraber and Andre Lucot from BMW will be announcing the 4 winners of each of the 4 challenges on Thursday at 10 a.m. So come along to that. It'll be fascinating, I assure you. Couple of quick ones to wrap up. So working with global systems integrators and partners, so with ContentWise and Moviri, there's a blog post up there looking at the problem of personalization, so kind of the Netflix personalization problem. How do you know what you like when you've never used Netflix before, and to offer that up. And so ContentWise did a proof of concept with us to work on the D-Wave Advantage via Braket, define a QBO for that problem, and run it through its process. And through that work, they invested in their own R&D, they invested in their own understanding of quantum computing, and were able to show some benefit to their customers in the way that they thought about taking on these particular problems. Again, looking at the architecture diagram, multiple services across AWS that then integrate into Braket. Finally, another enterprise example working with OI Insurance Services. This is looking at a binary classification problem with telematics data. So looking at like a fail, no fail condition. So how do you split in safe, not safe, binary classification. And they worked through a machine learning problem, a quantum neural network on Braket, and made that code available on GitHub. So as part of this blog post that's linked here, you can download this code, look at exactly the same data that our insurance customer looked at, rerun that same problem, use your own data sets, and contribute to the field as well. So we're really excited to see these kind of enterprises contributing to the overall conversation as well, and publishing some of this work through this mechanism. So finally, before I wrap up, a couple of advertisements from my colleagues who have got some presentations coming up this week. So Simone Severini, Director of Quantum Computing at AWS, he's on tomorrow morning. Simone will give a much deeper overview of what we're up to in Pasadena. So please come along to Simone's talk. You'll get a high-level understanding of the overall vision for AWS and the path that we're taking in quantum computing. I've already mentioned Thursday morning, the winners of the BMW Quantum Challenge will be announced. So Andre and Helmut, who are here, will talk you through that. We'll also talk you through the way that we approach this problem together, the integration between the AWS team and the BMW team to construct the problems, to seed the ideas, to do the assessments, and do that kind of work. So it's a great case study in problem formulation and problem selection in an enterprise environment. So please come along to that. So just to wrap up, key takeaways from today. Braket's available. It's been available in general availability for 15 months now. We're building up that operational experience in operating quantum computers in the cloud, integrating it into other services, working with a broad range of customers across research, startups, and partners. We've made a long-term commitment to the R&D of quantum computing and taking on some of those fundamental challenges to bring the technology to commercial fruition over a multi-decadal timeframe. And we're working with customers and tools and partners to bring more and more tools onto AWS to make it easier for all of you to get access to the systems and play around as well. So happy to take any questions.
We do have time for a question. Any questions out there? Yes, I see one back there.
Yeah, so the question was, is there a requirement for in the hybrid jobs format for the quantum work and the classical work to be co-located? The answer is no, not a requirement. It is optimal to be as close as possible, and that's something that AWS manages on your behalf. So as part of containerizing that unit, you specify which device you would like to target, so say IonQ, and then AWS will manage the classical allocation that's best suited to get the optimal performance out of that.
Okay, since it's time for break, I suggest we give one more round of applause to Michael.